This is part 2 of 8.01. Quarks make up protons and neutrons. Protons and neutrons are made of quarks. Quarks have strong nuclear attractions and charges, which hold the nucleus together. Although there are 6 types of quarks, you will only learn about 2 types here. Up quarks are particles with a positive 2/3 charge. Down quarks are particles with a negative 1/3 charge. Protons are made of 2 up quarks and 1 down quark. So when you add up the charges, since each up quark is worth 2/3, so 2/3 plus 2/3 plus a negative 1/3 for that 1 down quark gives you the positive 1 charge. So that's why protons have a charge of +1. Neutrons are made of 1 up quark and 2 down quarks. So the up quark is worth 2/3. Both of the 2 down quarks are worth negative 1/3. So 2/3 minus 1/3 minus 1/3 gives neutrons the charge of 0. What are electrons made of? Now that you know what makes up protons and neutrons, are you wondering what makes up electrons? Electrons aren't made up of anything else. Like up quarks and down quarks, electrons are a type of fundamental particle called a lepton. Leptons are not involved in holding the nucleus together. While quarks exhibit a strong nuclear attraction, leptons exhibit a weak nuclear attraction. I added to our notes protons made of 1 down and 2 up quarks. This is why protons have a positive 1 charge. The down quark has a negative 1/3 charge. The 2 up quarks are each positive 2/3. 2/3 plus 2/3 minus 1/3 gives you a charge of 1. Neutrons made of 2 down and 1 up quarks. This is why neutrons are neutral. Attraction between quarks holds the atomic nucleus together. So why doesn't the nucleus fly apart? And the reason they're asking that is because the protons are in the nucleus and protons are all positively charged, and of course positive charges are going to repel. Neutrons keep protons apart because if protons get too close, they will push each other away. However, protons still need a force to keep them together. What's the missing force that holds them together? Attraction between quarks holds protons together. This force of attraction is called the strong nuclear force. The strong nuclear force is so strong that it goes beyond the proton and pulls on quarks inside the other protons, keeping the atomic nucleus together. This force that attracts quarks and adjacent protons is called a residual strong force. So they are attracted to each other and they're attracted to the adjoining one as well. The strong nuclear force is the attraction between quarks. The residual strong interaction is the attraction between protons. So I added the strong nuclear force, attraction between quarks holding protons together, and the residual strong force, this force that attracts quarks and adjacent protons. Stop and review the structure of the nucleus and the forces within it. The nucleus is made of protons with positive 1 charge and neutrons, which are neutral or a 0 charge. Protons and neutrons are made of fundamental particles called quarks. Up quarks are particles with a positive 2/3 charge. Down quarks are particles with a negative 1/3 charge. Protons are made of 2 up quarks and 1 down quark. So positive 2/3 plus positive 2/3 plus a negative 1/3 equals your positive 1 charge. Neutrons are made up of 1 up quark and 2 down quarks. Positive 2/3 plus a negative third plus a negative third gives you your 0 charge. Quarks attract each other to hold protons and neutrons together via the strong nuclear force. Quarks from one proton attract quarks from another nucleon, so either from another proton or from another neutron. The strong nuclear force acts over a short distance. And I just added that last paragraph to the notes. Nuclear chemistry has various applications. The strong nuclear force is a powerful one, so nuclear reactions release a great deal of energy, usually in the form of radiation. We can use this energy for several purposes. Nuclear medicine uses the energy from nuclear reactions for diagnosis and treatment. Visualizing parts of the human body for diagnosis, so x-rays, CT scans. Treating illnesses, radiation therapy for cancers. Nuclear power uses the heat released from nuclear reactions to make electricity. Nuclear bombs release heat and radiation from nuclear reactions. So a technician examines images of a patient's brain made from using x-rays emitted by nuclear reactions. A nuclear reactor heats water to make steam to generate electric power, like in Monticello, Minnesota. And a mushroom cloud forms at a nuclear bomb test site. So nuclear energy is used for medicine, to make electricity, and bombs. Nuclear chemistry involves changes in the composition of the nucleus. Protons, a positive one charge, and neutrons, a zero charge, make up the nucleus. Protons and neutrons are made up of fundamental particles called quarks. Quarks attract each other to hold protons and neutrons together via the strong nuclear force. Quarks from one proton attract quarks from another nucleon, so another proton or a neutron. This is the residual strong force, kind of like residual meaning leftover. So the strong force keeps the quarks together within the proton, and then one proton wants to be next to another proton because of the residual or leftover strong force. Nuclear chemistry has many applications. Nucleus composed of neutrons and protons, and they are both composed of quarks, which again is why together they are called what? They're called nucleons. And that's it.